I'm here in Wellington Harbor with my good friend Lapo Ancillotti, and we're going to give you a little description of what a Class 40 racing sailboat is. Now, Lapo is the brainchild behind Bodacious Dream, and we sailed the last two Atlantic Cups, did pretty well on them, and Bodacious Dream is now in Wellington, so we'll miss this year's Atlantic Cup, but this is the boat here. So Lapo, tell me a little bit about what the design rule of a Class 40 actually is.
Class 40 is a class that's been created by the French about 10 years ago, and the purpose was to have a safe and powerful small ocean racer. So they instead of creating a formula with a combination of different dimensions together, they create a box rule. A box rule is a rule where you define the dimension, the max dimension, and the designer have to stay within that dimension. So at the end of the day, the task is to get the most out of the dimension you'll be given by the rules.
So the Class 40 rule dictates the length of the boat as 40 feet, huh?
Yeah, it dictates the length of the boat, the max beam,
the width, which is the width of the boat, the max.
Max draft of the boat, which is
so how deep the bottom of the keel can be.
The length of the rig from the waterline.
So the height of the mast and up, and then it dictates the size of the sails as well, doesn't it?
Exactly, and the size of the sails, the maximum size of the sails, and the maximum sail area, and the maximum number of sails you can carry on a boat.
Different things in the rule that try to bring, actually, it tries to give different designers the flexibility to design what they think is fastest, but keep everybody in a pretty tight range.
Yeah.
So the boat speeds are relatively comparable, and then that kind of creates a little bit of magic for the designers or someone like yourself to maybe tweak the design to what you think is the best thing, but still stay within the tight constraints of the rules.
Yeah,
right?
That's correct. The original was to put everyone on a equal terms and makes the boat very similar to each other. Being the opportunity to different designers to develop, for instance, different highlights, within the same length, the same width, and the same draft, you can actually, create different arc shapes. And so the architects start basically competing between each other on the geometries, on the arc shape, or where about are you going to put the key. The fin and the keel will be forward, will be more after. Where I put the rig, do I want a bigger mainsail and a smaller jib, or do I want a bigger jib and smaller mainsail? So this has been the original contest between the designer, and along the track, the boat start to be quite similar, because they start from the opposite corner of the box, and in the matter of a few years, the best approach to the arc shape and the general geometry has been identified, and the boats start to be very similar. So when we get to the arena, we say, oh, where about we can improve that, and so there was definitely an area for improvement in the arc shape and the general geometry.
This boat was designed by Bruce Farr,
the boat was designed
who was originally a New Zealand guy and now lives in the U.S. or works out of the U.S. And had one idea of what you thought should make the best design. Now there's other designers from France. There's the Finot group and the Verdier group, and chief designers Murph Owen, and they all have their own ideas. But like you say, after Bodacious Dream is probably a third and a half generation boat, would you say, or fourth generation?
Probably is third generation.
So third generation.
Third generation boat.
Really unique is just last night this first generation boat, Krakatoa, sailed into the harbor right across from us, and you can see it's a uniquely different shape than how wide and boxy Bodacious Dream is, but that's the evolution of the design, and what, as Lapo said, various different things start to narrow themselves down as to what's fastest, and then they start to concentrate on the speed advantages they can get out of that.
Yeah, and we set up, two main areas we're working on is increasing the stability of the boats, and that's being made by putting a hard chine. As you see, this corner they
So the hard chine that Lapo's talking about is this hard corner edge here on the boat.
That's it.
And what is that? You see that mainly on boats that race long distances and predominantly sort of off the wind. How does that actually work? What is that actually supposed to do?
Yeah, basically when you heel, you still got quite a lot of volume, and so the boat will have the benefit of an additional stability by the volume that been taken outboard through the chine.
So the boat when it heels over and leans over, it kind of leans on that edge, and kind of gets a what we call form stability from the resistance of that edge to want to go further into the water.
You increase the form stability.
So when you look at Krakatoa here, you don't really see those hard chines in there.
Exactly.
So she doesn't have quite the form stability, right?
Exactly. And the form stability is actually the result of having more volume located more outboard from the center line.
So if I understand he's designed things right, by coming up here with a chine, stopping and coming up, you're kind of faking the water out by making it think the boat's actually a whole lot wider, right?
Yeah.
So the boat feels that the water and the wind thinks that the boat's maybe 18 feet wide, but it's really only 14 feet wide. Is that how that's working?
Absolutely. And on the other side, on a windward side of the hull, most of the volume, most of the surface of the hull will get out of the water. So you got the additional benefit of having more stability, so more horsepower, and less surface of the hull and water on both sides. So you reduce your drag. You increase your stability, you reduce your drag, you increase your speed.
So what Lab was saying is when the boat heels over and is sailing this way, the water probably starts right about here and ends somewhere about the chine. So the boat is really only that wide at that point, which gives it, like you said, less wetted area, a very narrow boat, which is very fast upwind, right?
Yeah.
But then downwind, you level the boat out more like it is, and you can still see the water line there. And the boat's kind of heavy right now because I've got it loaded down for heading around the world.
Yeah, normally the water line is just on the edge of the transom down there.
So you have kind of relatively the same wetted surface, maybe a little bit more going downwind, but in a different location of the boat, making it feel fast as well that way.
Yeah, absolutely.
So it's a constantly changing geometry of the boat depending on how it's sailing, right?
Yeah. The other point was whereabouts we want to have the BMX, and that is going to determine the way the boat is going to heel. If the BMX, which is the max width of the boat, is further aft, the boat will heel in this way, and the front part of the boat, the bow, will go into the water, which helps the boat upwind. And if your BMX is further forward, the boat will heel in this way, not on this way. So heeling this way helps the boat reaching. So it's the combination of all these factors that determine the winning design, different from other boats. And we tow all the lines down below in a tunnel and back to the cockpit. Is that clear?
Yeah.
All right. So that allows us to lower the center of gravity, to lower the weight of the halyard from the cabin top to the bottom of the tunnel.
So just that you mentioned lower center of gravity. So just for some of the students and stuff that might not understand sailing but understand cars, the same type of thing. The lower the center of gravity of your car, and the further out the tires are, the more stable the car is and the faster you can turn. Yeah. So we're kind of in the same, doing the same thing.
And in fact, on a Formula One and a racing car, they limit the width of the car, because you may build a wider car and you're going to be faster because you're going to be more stable on turning. I mean, the composite is pretty much the same.
Pretty much the same.
And lower the center of gravity, increase your stability on a cars as well as on the boat.
Let's take a walk up to the end of the dock here and take a look at the boat from a different angle, and we can see what the bow looks like here.
You see.
So here you can
how
see
big are the volumes on this part of the boat, and
so you can see the pronounced hard chine there. It goes most of the way forward, almost to the bow. Each boat is slightly different on this. If we put 4 or 5 of the latest generation boats side by side, you could see the subtle differences, and that's just each designer's sort of magic formula for making the. So if you had 5 different cooks making different chocolate chip cookies, each one might adjust the recipe slightly to what they think is the best flavor.
Yeah.
And the same with sailors. You're going to find some sailors are going to sail certain boats faster than other ones because they have a better feel for sailing a boat that sails this way or that way, slightly different. So it's not just the boat design that makes it fast, but how a sailor actually uses a tool.
It's every boat needs to be learned in a way they sail. I mean, the skill of a sailor is understanding his boat, understand where the boat can express the performance. Every sailor on each one of the boys they can. In this particular case, we want to put a lot of volume on a bow, and we want to keep the B-max quite far after. So we want to have the benefits of having a boat that was going fast upwind, was as much as possible controllable on a reaching condition. So the B-max far after.
I can tell you what I know the boat to be fast is at, because we've had some great successes with racing it. What would you say were the best angles of racing for the boat, and did that meet your expectations when you guys worked out the design and such?
Yes, actually, the first few sailing has been amazing because the boat was exceeding the expectation. It was going really, really well, extremely well. I mean, the design briefing was calling for a all-round boat. So means faster in every condition. Means upwind, reaching, big wind or light wind. Obviously, everyone wants a boat that's going to be fast in every single condition, because if you optimize a boat for only one condition, you're going to be faster on only that specific race.
And
so
the races give you different conditions, huh? So one race across the Atlantic might give you mostly reaching or downwind, and another race across the Atlantic might give you a combination of upwind and downwind.
Yeah.
And so you're trying to reach, like you say, an all-around performance.
Yeah.
So the boat can perform in all the races, not just on ones that are particularly downwind or ones that are particularly upwind, huh?
That's correct. Exactly, because the Bodacious Dream and QB40 has been designed to race possibly everywhere in the world, around the world, as well as inshore in Europe or inshore in the United States. So we couldn't optimize the boat for one specific race, because that would have been very weak on other races.
And this boat, Bodacious Dream in particular, has raced all those races. We raced a couple of years of the Atlantic Cup. We raced across the North Atlantic in the Quebec St. Malo.
Yeah.
We raced the Normandy Channel race, and we raced the Worlds over there, and now I'm sailing it around the world, which was intended to be the Global Oceans race. So
exactly.
it's getting its work out.
If you see on a list of races that you mentioned, if you see the Channel race is mostly upwind race, I mean traditionally, where other races are mostly reaching race. Crossing the Atlantic from France to Europe, like race like the Trans-Saharan Jacques, there's going to be mostly reaching race.
Yeah.
The first week is going to be upwind, but the rest of the race will be all reaching. So there are people that actually optimize the boat for winning that specific race. So they design a boat that's going to be faster only when reaching. Upwind are not that strong, because the boat has been designed to win in that race. In the case of QB40 and Bodacious Dream, we want something capable of racing in every single condition.
And pretty much succeeded with that, I guess, huh?
Oh yeah, no, it's great, absolutely great.